Hello, and welcome to Instant Replay Education's introductory demonstration. We are using the latest technology available to capture a lecture so that you can play it back at another point in time when you're ready to review your lesson, do your homework, or study for an examination. Quite simply, Instant Replay Education is going to give you the opportunity to review the steps that you've learned in class. By using Instant Replay Education's program, you won't have to ask somebody else to explain something to you, and you won't be confused by their words, different words than your instructors. You will hear your instructor's words as often as you need in order to make the material stick. After all, your instructor is the very best tutor when you're ready to review the lesson. Most subjects, especially math, have a nasty way of being forgotten as soon as you leave the classroom. But with Instant Replay Education, you will have unlimited opportunities to go back to your class so that you can see and hear the original presentation until you've mastered that lesson. By doing so, you can once again recreate that same knowing feeling that you've experienced during the class. You will see that this makes learning the material covered much more effective and helps you master the problem-solving skills. Doing the homework will become easier, and your test results will improve. Now let me pause this recording so I can shrink my image down a bit. Then I can start a beginning algebra lecture to show you how this system works. Hello, and welcome back to the introductory lecture of Instant Replay Education. Now, it is worth noting before we get started that while you're in the classroom, it's my job as the teacher to explain the subject matter in the best possible way that I know how. And that it's also your job as student, when you're hearing this live, to stop me, raise your hand, and tell me if you don't understand any of the steps, and we can handle this problem while it's still in the classroom rather than going home and trying to figure it out. So everyone should be concentrating on my presentation and not on note-taking. A printable version of the class notes will be available after, so that will just free you to listen and learn and ask questions at the exact moment when you don't understand something. So why don't we get started with this, with the lecture? And as you can see in front of you, we have a list of all of the basic operations that you should be familiar with from arithmetic, and the operations are addition, subtraction, multiplication, and division. Now, although that's a subtraction symbol, it also is that dreaded negative sign. And that negative sign, along with bad arithmetic, is going to be responsible for about 75% of the mistakes that you'll encounter in a beginning algebra class. So it's important that you learn the beginning concepts quickly, easily, and effectively so that you don't make these mistakes along the line. So let's see if we can scroll down a little bit. These are the charts that are normally included in most algebra books, but I find these charts a bit cumbersome, and I personally don't like memorizing this stuff. And the book that we have, that we're going to be using, deals with the idea more of concentrating on a thing called the number line than it is on memorizing charts. So first of all, let me draw a line, and a number line or a line is infinite in both directions. At some point we'll put a mark, and that mark we'll call the 0 point. The distance from that mark to the next mark on the positive side, because as you know, the 0 point separates the positive numbers from the negative numbers. The distance from 0 to that mark we'll call 1 unit, and if we copy it, we'll get 2 units, and 3 units, and 4 units, and so forth. Now, if we copy it on the negative side, we're still 1 unit away, but being on the left side of 0, we'll be on the negative side, and that will give us a -1. If we continue to copy these marks, we'll get -2 and -3, and so forth. Now, to give us an example of how we can use this number line, let's take a simple problem of 2 plus 3. Now, obviously, it doesn't take a rocket scientist to figure out what 2 plus 3 is, but in my experience, by practicing when the problems are easy, it will give you the same concepts and the exact same procedures as when the more difficult problems come about. So let's see if we can just take our time on something like this. Now the first thing I'm going to do is put these in the parentheses, and I've always thought that parentheses is cheap insurance, because once you separate this, you're looking at a little piece of the puzzle rather than the whole puzzle together. And inside the parentheses, I'm going to slip in a positive symbol. And I know that many teachers say that it's not necessary to have the pluses, but I feel it only takes a moment to write, and once we get into the idea of direction, whether we're going to the positive side or to the negative side, they can be very helpful. So let me go to the color palette, and we'll get another color here. And at first we want to add a 2 plus a 3, and by doing so on the number line, we'll start at the 0 point and we'll go 2 units in the positive direction, and if that's all we did and stopped here, we would get a positive 2 as my final answer. However, to that we want to add a positive 3, and that means that from the ending point of our first step, that will now be the starting point of my second step, and we want to go 3 units again in the positive direction. Now it may not be drawn to scale, but you can see that 2 plus 3, by counting the lines, will give you 5. So a plus 2 and a plus 3 gives you a positive 5. Now, not always will we be dealing with positive numbers, and again, my first example was done just because it was easy. But what if I had a negative 1 and I wanted to add to it a negative 4? Let's scroll down and put ourselves on another number line. And on the number line, let's start with 0. Let me undo that little mark here. And we could start with 0, and I want to take a negative 1. So instead of going in the positive direction, I'm going to be going 1 unit in the negative direction, and as you can see, that brings us to the negative 1. If I stopped here, that would be my answer. But we want to take negative 1 and add a negative 4 to it. And even though we want to go to the right, this negative 4 pushes us back to the left, and we want to go 4 units more to the left from negative 1, and that will give us negative 5. Now I know many of you want to start drawing little lines on here, but what if I had negative 317 plus a negative 108? There'd be a lot of lines drawn before you get to an answer. So let's first just get used to the idea of what kind of process we go through. Now, is there a way of generalizing this particular type of arithmetic? And the answer is yes. If I take any positive number and add it to another positive number, I will always be on the positive side of this 0 point. And yes, there's a chart, and you can memorize it, but I believe that if you visualize what's going on, there's no mistakes, no way of misinterpreting things. So a positive plus a positive will give you a positive. And in a similar way, if we were at the 0 point and we had a negative plus another negative, this will yield a negative answer. No way to be able to flip over to the positive side because we're sliding back and forth on the number line. Now, in both cases, we've had the same symbols, both pluses or both minuses. What happens if I have one positive, say like a plus 2, and I want to add it to a negative 5? Now, in a situation like this, again, we use the number line. We first go 2 units in the positive direction, and that will leave us at plus 2. Again, we stop, we're done at plus 2. But from the plus 2, we want to go 5 units in the negative direction. And this more than knocks off all of the positive that we have. It lands us in negative territory at specifically the negative 3. So will a negative and a positive always add up to a negative? Absolutely not. I wish we had a rule for this, but the best rule that you can think of is that these are like a tug-of-war. You have something in the positive, something in the negative. Whichever is stronger is going to win out. So if I had a plus 6 and I wanted to add a negative 3 to it, my first movement would be 6 units in the positive direction, leaving me at plus 6, and my second movement would be at 3 units in the negative direction, leaving me with a positive 3. So as you can see, sometimes we end up with a negative number, sometimes we end up with a positive number, and it all depends upon which one has more clout. Now, I'm going to stop at this point, and then we're going to show how to print the lecture notes out, and we get some idea of what real-time presentation, how it differs from just seeing notes laid out. So let me stop this for a moment. Okay, now that we've had the opportunity of seeing some of a little piece of the math lecture, we're going to use this program to see if we can download a printable version. Now that you've been watching, hopefully closely, and you understand all of the process, let's retrieve the notes. Now, as you can see on the File toolbar up above, if we click on that and go down to Print, we'll be able to see the notes that were generated by me, and if you hit the Print button, that will throw the program to my computer. I'll hit Properties just to make sure that it's black and white and draft, so it will be able to print out in a few seconds. I'll hit OK, and a couple seconds later, let's see if we have all the notes. And these are notes that you didn't need to take. You can certainly always write on them afterwards, but at least now you haven't been watching my lecture partially and watching your note-taking partially. And here we have all of the notes, and this you can refer to, punch holes in it, keep it in a notebook, and the next time you do your homework or study for a test, all you need to do is look at your notes that I'm providing, as well as look at the recording to see how everything is done, just to make sure that you understand. Instant Replay Education is not just a way to show you right answers, but it helps students develop the skills necessary for them to get the right answer. On the screen we have an example of note-taking during an arithmetic class covering multiplication of fractions. When students leave the class, they have a certain degree of confidence, having just seen the lecture. But once they decide to do the homework, they may have forgotten the processes necessary to get a correct answer. Now let me try to do the problem on the screen, and we'll see what the process is. Right now I see a multiplication of fractions, and I see an enormous mess here that constitutes the working of this multiplication that results in a 1/12. Now, we know that from previous discussion in arithmetic, we know that if we reduce along the way, it saves us a lot of grief in reducing along a huge fraction at the end. So what I'm going to do is show you the processes. Right now I can't figure out what's going on over here, and I've taken the liberty of writing this again. So what I'm going to do is see if I can show you the process, and in this method you'll be able to, using Instant Replay Education, play back the lecture so that this indecipherable stuff will be understandable. Now, in the multiplication of fractions, we multiply top times top times top and divide it by bottom times bottom times bottom. Also, what we want to do is understand that the concept of reducing is the ability to divide anything on the top by a number as long as it divides the bottom by that same number. And the reason why I say anything on the top is that in multiplication the operation is commutative. It has the ability to switch the order of the terms, so 5 times 26 is equal to 26 times 5. Now, knowing that, we notice that we can take the denominator of 13, divide it by 13, and get 1. We can take the numerator of 26, divide it by 13, and get 2. Once we have a 2, we can take 2 and divide it into 2 and get 1. We can take 2 and divide it into 8 and get 4. So that's my first foray of divisions. On the top now I am left with 5 times 5. On the bottom I have 75. Now I know that the first 5 will go into 75. I'm not so sure about the second, but I think I have a better way of doing it. If right now I multiply 5 times 5, I would get 25. And I know from all my life of making change, 3/4, 3 25-cent pieces equal 75 cents. So if I divide 25 into 25, I get 1. I divide 25 into 75, I get 3. Everything cancels, so what we are left with is a series of ones on the top, and if we multiply all the ones together, we get ones. On the bottom, if I have 3 things to multiply, I multiply 2 at a time. It gives me 3, and then take that answer and multiply by what's left, and that would give me 12. As you can see, we do get an answer of 1/12, which is what we were told, and now, even though this is a mess, you'll be able to play it back and see the steps that were required to get this fraction reduced. Now, with instant replay education, students not only have the correct class notes, but can go back to the presentation, as I've just said, to review the processes necessary to get to the right answers. And by the way, I say correct class notes, as you wouldn't believe how many students decide to get creative when they copy the lecture that I have just given them. So now the process can be reviewed until they are proficient, having the correct class notes and the correct operations in sequence that we've just gone through. Now, by doing so, the student will be able to do the homework and practice it correctly. They will also improve on tests by reinforcing the proper skills. And they will be able to fill in the spaces that they might have accumulated with a deficient background in other classes, but not only will help them in the class that they're taking, but also in subsequent classes. They should be able to increase student confidence by gaining successes in their homework, in their tests, and any other materials that are given them in their classroom. And lastly, they should be able to build a solid foundation from which to master subsequent skills, so we will truly leave no student left behind. This is the conclusion of our demonstration. We at Instant Replay Education thank you for watching and trust that you can appreciate how our program can assist students in achieving higher grades, retention of skills, and increasing student learning outcomes. Should you have any questions related to this extraordinary breakthrough in student learning, or wish to hear more about the self-funding, revenue-sharing business plan that monetarily rewards both teachers and schools, please contact us at the numbers provided on the screen. When you see how attainable quality education can be by our truly unique educational system, we know that your school system will soon subscribe to Instant Replay Education. We look forward to speaking with you soon.